Hello. Thank you. Can you hear me?
Yes, Etikan, I can hear you, but I'm outside a bit noisy here. Hi, Etikan. I think we can start.โอเคสวัสดีค่ะงั้นขอเริ่มกันเลยนะคะก็คือวันนี้เซสชั่นของ NVIDIA ก็จะมาสอนมาแนะนำ AI SDK framework ต่างๆที่มาช่วยในการทำโปรเจกต์ AI ให้เร็วขึ้นอะไรประมาณนี้นะคะซึ่งจะ cover แทบจะทุกsegment ทุก industry เลยมีคำถามสามารถถามได้นะคะวันนี้แป้งตั้งเป็นCountry Manager ของ NVIDIA นะคะ Thailand Enterprise Country Lead แล้วก็อยู่กับเอติกันนะคะเอติกันเป็น Head ของทีม DevRel นะคะจะมาช่วยเล่าเรื่อง SDK ของ NVIDIA ให้ฟังค่ะโอเคเอติกัน over to you Hi Etikan do you hear me I think you are on mute
Okay, sure.
Yeah.
Can you see me? Okay, you can hear me now, right?
I can see you and can hear you now you can start yes
Okay.
Thank you.
Is the screen is visible? My slides, which is presentation slides.
I can see your slides.
Okay, good. A very good afternoon to everybody who's joining this session here, organized by BOTNOI and also their partners. And thank you very much for having NVIDIA. And my name is Atikan. I'm the technologist here for NVIDIA, Asia Pacific South region based out of Singapore. Right? So I'm going to cover today about NVIDIA SDKs for your development and research activities. How can you leverage? Now, let me do a quick overview of NVIDIA. I'm sure everybody knows NVIDIA today, and one of the famous application that all of y'all know, it's a GPT type applications, right? It could be a chat GPT is one example. That is powered by NVIDIA GPUs, 10,000 of them, which has been used by OpenAI. I'm starting that as a quick introduction so that you understand the power of AI, the power of GPU, and the power of entire software platform SDKs, which enabled one application, which is called the chat application. So NVIDIA can be seen as a stack computing company. You may know very well of our gaming GPUs, which has been used for almost 30 years in a gaming industry. But the same GPU also used for accelerated computing, right? For example, HPC related application development. The same GPU is being used for movie making, which is basically for rendering type of activity. The same GPUs in the last 10 years being adopted in AI. And today the same GPU is being adapted for large language models. So beside GPU, which is graphic processing unit, NVIDIA also has what we call as a DPU, data processing units. You can see the bottom down there. I've colored them in the red color box. DPU is data processing unit in order to accelerate the network packets, right? We are in a fully connected world. For example, we have a 5G, which gives you XX of megabits per second in your mobile phone. Now, this mobile phone can able to bring low latency, sub-millisecond type of applications. It could be a gaming applications, it could be streaming applications, and so forth. So that requires also accelerated computing with the high-speed packet processing by using DPU, data processing units. Next is CPU. Do you know that NVIDIA has our own CPU, right? This is for, we have started for accelerated computing, where large amount of workloads need to be computed based on ARM type of technology, right? It's basically ARM CPU, but it has many ARMs, 72 ARM cores in a single die, so that it can perform data center type of application. So given this is the core technology by NVIDIA, which is the CPU, GPU, and DPU, it then put together in a various forms. For example, it could be a server, right? The server that you have in your universities or in the cloud, right? DGX, HGX, EGX, all these are the form of GPUs in a compute environment, compute architecture. The next, all these are being accelerated by our full stack solution, which is all the libraries, framework, SDKs, platforms, middleware. Right? All that is a complete environment ecosystem of software that we provide, which then enables your own application development. You may develop applications for example, avatar development, right? You may have developed applications for autonomous driving, AV vehicles. You may develop applications for your robots, flying robot, swimming robot, crawling robot, right? Or you can actually develop conversational AI using Nemo framework, or you can use it for a video streaming type of application using DeepStream, Maxine, and so forth. So there is many application framework to help you to develop final application. I'm going to share with you some selected SDKs. But before we get into all the details, why is NVIDIA doing so well in the last 10 to 15 years, right? One of the important factor is in the last 20 years, we have moved from graphics and display type of company to a complete HPC solution, then AI, now in a generative AI, right? So the move of this is very, very fundamental to all the scientific design and development, scientific discovery, right? So if you see from the year early 2000, the accelerated computing HPC type of application, whether it is climate related, whether it is in highly scalable applications like molecular dynamics, Ember, GrowMag, and so forth, we have started. And we have seen the same accelerated computing is required across different areas. If you can, the green color line actually shows very well how the compute performance of GPU is ramping up with extreme fast pace compared to CPU. CPU is tapering off with about 1.x times the performance gain, but GPU is going into hundreds, if it's not thousands of x performance gain over the years. Now, with this speed up, what does it enables, right? It enables you to do all kind of a research work, right? And NVIDIA AI platform is for all. Either you are a student developer, whether you are a researcher doing your final year project, or you're master students or PhD student, right? You are an industry developer. All of you can use all our frameworks which is available. I'll be sharing next for your fast development using the three chipset that we have, right? So categorically, you can actually group the type of AI application, either data science related, right? Whether you're a data scientist working on machine learning algorithm, scikit-learn, you are doing random forest, you are doing PCA, or you are doing graph analytics, or you are doing uh, some kind of gradient boosting. All these analytics are being covered by a group of libraries or SDKs called Rapids. If you're doing database acceleration, an SQL type of acceleration, Spark and like libraries will help you. If you're doing optimization of routes, QOpt will help you. If you're working on, you are a cloud-based company or consumer internet-based company developer, or you're planning to join any consumer-based companies, right? A recommendation is very important. How do you personalize a recommendation? Push to a developer. There is complete SDK called Merlin that you can use. If you're working on a speech or vision related, right, we call it as a conversational AI. There is the ASR, there is the TTS, there is the NLP, and the large language model. Right? All these comes under a framework called NEMO, N-E-M-O. We will look at it simply later. Right? And then it's not only NEMO, but it has many other group of SDKs. It could be Riva, it could be a deep stream, which is relevant to you, right? Go and explore. I'll be sharing these slides after the talk. Take this slide as your reference and browse the entire rich software libraries ecosystem that we have. Next, if you were to deploy all your application in a production environment, either on-prem, whether in a hybrid environment or in a cloud, we have a complete suite of application which is enabled. It's all our framework and libraries are Dockerized, containerized. Easily you can develop and deploy in scalable environment, for example, using Kubernetes, right? And the Triton is one of the SDK which is very, very important for a fast scalable performance of inference activity, right? And finally, Nemo Megatron, which is for large language model or Gen AI type of application. So all these SDKs are available for you to use. And the way that you can actually understand, regardless whether you're using GPU in the cloud or in the data center, or whether you're using embedded Jetson at the edge, right? All these, it's actually a common architecture, common platform. So you can develop an application using your gaming PC at home. The same application, you can bring it to your lab, get it implemented in your lab data center. Or you have access to AWS, Azure, or GCP. You can have the same application running in a cloud, or you actually want to run it on a Jetson embedded GPU, you can run it even in a Jetson. So whether it's a workstation, whether it's a data center cloud, the same code base can run across all GPUs, right? So regardless, whatever your NVIDIA and applications, you just can install, download, and run all this our framework and library. Now, next, if you look at it, why is NVIDIA AI GPU is so good? If you see the framework reference, this is what we call MLPerf. MLPerf is an independent benchmark organization which benchmarks all different type of hardware across different type of softwares, either for a training or inference in AI space. Over here, you can see NVIDIA always comes to the top in terms of AI inference, AI training for all kind of workloads that you are working on. Okay, so because of the ability of GPU to do parallelization and acceleration across different type of workloads, any GPUs that you're using, whether it's an Ampere architecture, whether it is a Hopper architecture, or whether it's a Volta architecture, or whether it's an Ada architecture, the same code base will actually run and gives you the best performance. Next. Now, I shared with you the whole DPU, CPU, GPU. It's totally hidden for you. The whole software stack is actually containerized, Dockerized. It is ready for enterprise type of deployment, or even for the faculty type of deployment, or even at home in your same gaming PCs, you can deploy and work on this, right? Now, just to briefly to share with you, as I highlighted early in my speech, we have the GPU. The latest GPU that we have is called Hopper-based architecture, H100. Right? It has the world best AI and HPC performance. It actually optimized 2 years ago. NVIDIA already knew transformer-based models are very, very important for today's application. So we have invested billions of dollars and started a R&D work 2 to 3 years ago, specifically on transformer-based architecture. And today it is just right time, as everybody talks about ChatGPT, which is a transformer-based model. NVIDIA is there to give you the right GPU architecture for you to train your large language model. It gives the best utilization. It gives you the best TCO, total cost of ownership, for you to explore. Next is CPU. So this is called Grace CPU. It also gives you the best CPU performance that you need, which runs on top of ARM-based architecture. It gives you power or energy efficiency. It gives you 2 times of density of chipsets or silicon within the die to give you the best performance that you need. And today, some of the leading centers are using it for their own development work, and soon it will be available in the cloud. Right? And finally, we have combined the CPU and a GPU together so that it brings both good value of CPU, GPU in a single chipset. It's available soon. Right? Some are already using it. So if you can see, NVIDIA is evolving as a top CPU, GPU, DPU compute company. So it's very important for you to understand how you can do a program, develop your program across various architecture. Now, finally, is what I call, I shared with you, a DPU, data processing unit. So those who are studying or those who are working in network-related research, network-related development work, this is very important as we go to software-defined network. The network operations, whether it's a control plane, management plane, data plane, whether it's a protocol implementation, whether it's an application implementation, or whether it's a management type of application on the network. Network means is connectivity, right? All these are now being ported into GPU so that it gives you the best performance in the data center, right? And as I shared, roughly, all these are put together into a system. For example, it could be a DGX, but there are many systems available that you can consume GPUs. Right? This is widely available in Thailand, whether in the universities, whether in Thai SC, for example. All of them have various configuration, right? And there are many GPU accelerated applications that you can actually download, not only in AI, in climate and weather related, in a computational finance, data science and analytics, right? In the defense sector, life sciences, healthcare, manufacturing, media, entertainment, oil and gas, retail, supercomputing, and many more. Right? We have over 1,000 plus different application framework that you can use for your development work. Now, let me touch some few SDKs, right? I'll give you the long list, but I'll touch a few, right? Let's say AI, which is generative AI. Right? Generative AI is a big plus, but it didn't happen overnight. It took many years, many winters before we are at the current stage. Of course, as you know, Warren McCulloch and Walter Pitts actually started a first human brain type of neural network studies. He then followed by many other researchers like Alexei, Vijay Lapa, Kunihiko Fukushima, right, and so forth. Right? But The most important is in the last 10 to 15 years, we call the father of modern AI, Jeffrey Hinton. So he actually is the one of the key founder of the current deep learning techniques, right? From general AI to a deep learning. Now, he and his team, right, was helped with the GPU to accelerate the AI research work, which is the fundamental and foundation to where we are today. But in a nutshell, we are just trying to learn how the human brain is structured. You have the nucleus, you have the axon, you have the dendrons, and how are they communicating to each other? We represent it in a simple neural network, and these neural networks actually does very high computation. If you can see over here, it's just the summations of multiplication of the weight as the signal comes from one point to another point. So there is a input link, there is a weight calculation, there is an output link. So this actually requires a complex multiplication, and this is ideal for GPU. So by offloading all the compute intensive tasks to GPU, you have a high speed up capability to compute networks with a billions of parameters, right? For example, GPT-3 comes with a billions of parameters, right? Bloom model, which has multiple languages, including Thai language support, comes with 175 billion parameter. Okay, they have billions of neurons to be computed. So GPU is ideal. But end of the day, what is this AI so great? It can actually take an input. Of course, it's been trained with a large amount of data sets, its ability to comprehend and understand many data set, and then able to infer based on what it has learned. And NVIDIA has developed a very good model, a framework which is called NeMo. So NVIDIA NeMo, which allows you to work on large language model trainings, whether it's a T5, whether it's a GPT, whether it's a Bloom, whether it's a Alpaca, or many models. All these models are increasingly being supported by NeMo framework, right? This is for large language model. Next, the similar capability can be even used for biomedical space, molecule structure, chemical compound, chemical bonding. All these could be understood by using similar architecture, and that is available as part of the BioNeMo. Right? You can take a look at it. And finally, in terms of generative AI of imaging. So today it is not only large language text only. It is image to image, image to audio, image to video, image to text, and then video to text, video to image. It's anything to anything is what is being mapped, right? And for image related, video related, NVIDIA has an SDK called Picasso, right? And this NeMo service, so the NeMo, BioNeMo, Picasso, all that works on NVIDIA NeMo framework, which comes with the many foundational models. Go ahead, search for NeMo if you're in front of your computer, download NeMo and play with it, right? Now, why is this ChatGPT became so impactful, right? If you take a look at many famous applications, like a WhatsApp, took 49 months, right? It's about more than 4 years, close to 5 years, to reach 100 million users. If you take TikTok, it took more than a year before it could reach 100 million users. But ChatGPT only took 2 months, right? Within 2 months, 100 million users was achieved. And today they have 3 to 400 million users are using it. So that's a momentum it has created. Now, I always ask, so how does it translate into, into our actions, and how does it impact, right? So I'm just going to play a short video clip. I hope you can hear and look at this, a generated video using generative AI. a picture comes to life. So that's a simple illustration how a 2D avatar and portraits can be made to sing, right, with the expression. That is the power of generative AI. Okay. Okay. Next is we might heard about metaverse some time ago, right? It is still didn't go away. It is still at the background. It is doing a great work, right? We're just gifted with so many invention happening in a short period of time. So don't forget, it's a longer vision that everybody is working on. Right? So over here, if you can see, this is a digital twin of a factory environment, right? And as you can observe, whatever you can see here is not really physical. It's all digital. And sensors, right? For example, camera point easy to do a situation environment. You create computing operational research will have different workflows so that a factories many I would call products actually good environment for the workers in a demand, they can actually understand accumulate whole workflow. Now, from NVIDIA, we have designed an SDK called NVIDIA Omnibus. Try to download and play with this, which will help you to design different type of applications. The nucleus kit and simulation, I won't go into details, but it uses USD as a standard interface to connect across different type of third-party applications and also tools. USD is just a connector, and Omnibus is a platform to enable different SDKs, platform libraries, not only from NVIDIA, but also from our partners, whether it's Unity, Unreal Engine, right, Maya, Blender, all of them can put together to create the metaverse, right? And then they can collaboratively work with different people. It's just an example of list of many platforms that we are working together with USD as a standard connector interface or API in a simple form, right, to work with many of the other components. Now, the other important SDK, which is called HPC SDK, right, which is high performance computing SDK. Today, we made this available as a container Docker. You can actually download and install, right, from our NGC. It supports many programming models. Those who are fond exploring compilers, whereas NV compiler or NVCC compiler, right, or NVC++ compiler, or even you're working on a Fortran, right? You can actually go and download all these tools that it comes, right? From the compilers, programming models, whether you're using Fortran C++, whether you're using OpenACC, OpenMP. There is a collection of SDK for you to work on. It also comes with the many math libraries that will help you. For example, cuBLAS, cuTensor, cuSolver, cuRandom Generator, cuFFT, Fourier force transform, for example. It's supported many communication libraries coupled with profiler, right? In order to profile how the GPUs, how the codes are running on GPUs, whether it's the end site, whether it's a system for compute-related profilers, debuggers for you to debug and understand your code. All this comes as part of the HPC SDK. Now, beside the CE and Fortran, even Python is supported on a GPU so that you can run any Python code on a GPU today, right? Beside the standard OpenACC, OpenMP, and those who wants to do hardcore programming using GPU, then I strongly recommend start with CUDA. So CUDA will give you the best performance of a GPU for your own applications. Now, a simple illustration, right? If you were to write a C++ code, right? So this is basically you want to do transform. Transform is basically it's like a matrix multiplication that you want to do. Today, it made very simple for you to do a matrix multiplication. If you want to do it in OpenACC, OpenMP, just use the pragma in order to include certain interface so that you can actually run this on OpenACC or across using OpenMP across multiple compute architecture. That is supported, right? And if you want to do native, just use CUDA. Then CUDA will allow you to do. Now, this is important for those who are actually doing core programming work, optimization work, studies, communication studies between compute nodes, who are doing a core math, who are developing the libraries, who are developing the SDK, not using the SDK. This will help the researchers. Now, I shared a little bit about Python, right? But if you look at it, the Pi acceleration in the last, I would say the last 10 years actually has been seen a tremendous growth. So we have supported Dask, right? We have enabled data frames to be computed on a GPU. It's called a cuDF. Rapids is a complete solution that we have developed, make it available as an SDK for you to do accelerated computing, regardless any type of data science application can run on a GPU today. Those who are using numeric type of application like NumPy, right? You can use pure numeric library. It gives you enormous performance for your computation. This is a math library that I mentioned just now, and this is an example of compilers that you can download and you can actually try. Now, finally, I just want to touch a little bit of ARM. So NVIDIA CPU, right, which is called ARM, Grace, runs on top of ARM architecture, can do multiple type of application, whether you are working on a simulation like Omniverse, right, or you are actually using any of our tools, all our tools, right, whether it's libraries, profilers, debuggers, all that is today is supported. And we actually making it enabled to run for ARM. And data analytics platform, AI platforms, all that runs on NVIDIA Grace CPU. Okay, and not only the standard applications, we also support the HPC application. And list is available, download and try it. Right? Now, don't stop only with these few that I've suggested. I have a limited time. I can share with you all the SDKs that we have, but just to let you know, there are many more SDKs that you can actually use from NVIDIA. I'm going to highlight some of them, and later I'm going to run through a few guide that are able to help you so that you can try and use this guide. Next, my presentation is going to cover by using sample applications. It could be in the space of vision, it could be in the space of speech, face animation, body animation, gesture, planning, action of a task or conversation. All this requires multi-modality AI models, deep learning techniques, various type of data sets, type of multimedia to make this happen. So NVIDIA has many, many building blocks. You can pick some of this and develop on your own. So one example is what we call the Riva platform together with the Nemo as part of the I would call a framework for you to develop your own application. And the whole AI driven methodology for this can be accelerated by using a toolkit called Tau. Google and search Tau. Tau stands for train, adopt, and optimize. It's a toolkit to help you to do a model training, right? You get the data, you can annotate, and then you want to do augmentation. After that, train the model. So whether you're using, vision-based model, whether you're using audio signal-based models, any models, you can bring it into Tau, or you can natively train by using the tools like a framework like a PyTorch, TensorFlow. It's up to you, right? The Tau will help you to accelerate. Once you train the model, you bring it into Nemo. Once you have the model ready, you bring it into Nemo, then you train with different type of data sets and pre-trained model from NGC, NVIDIA GPU repository, right? Search for catalog NVIDIA NGC. And then you can finally develop applications using application framework. So Riva is an example of application framework, which you can use it to develop your final applications, right? And the conversational AI is covers automatic speech recognition or STT, speech to text to speech, which is TTS, natural language processing, and it also can cover computer vision type of applications. Let's see a simple audio. Right? I hope you can listen this. So in this case is understand the speech and transcribe that into a text. So if you can see here, this is the speech to text. The speech comes in, the text automatically created. So this is supported for many languages. I think it's more than 10. If it's not, you can train your own model. We have the pre-trained model. Try on your own. It will have for Thai language, for example. Next is text to speech. So it's made it simple by using SSML, speech synthesis markup language, for you to include this. Let's listen to this. So let's so over here, this is just to show how the pitch, the rate, the phenome, all that is being covered. Right? Now over here, let me just show a quick, demonstrate a quick model that we have trained, right, for text to speech. For example, we always recommend use Tegatron and Hi-Fi Gun as a combination for you to do your TTS implementation. So for that, this is a female voice. So pitch and tone has all been trained. You will get a good pre-trained model for a female voice or even for the male voice. Okay, so this is an example of a model that's available that you actually use it. Okay, now another similar group of SDKs, how we transform a speech signal into a facial muscle movement, creating an expression, right? So in this case, what you can see is over here, this is skeleton. And by using audio to face, you can actually translate the skeleton to a speech controllable item. Let me just make sure that it's the voice is coming through, right? Okay, so in case, if you see this SDK, which is called Audio to Face, you can download. It's free for you to try and use it. Right? So this is just a scheme of a person where by putting in to the audio file, it's able to move the muscles in the face, the lips, the chin, the cheek, right, the eyebrow, so all the key muscles in the face as he speaks. So we can train by using AI and then get it deployed for your own real-time text avatar, which is able to speak like this. It's a funny joke, right? Okay, great. Now, moving on, there is many other SDKs that I would like you to download and try. So this is for a fast AI building. You go to the ngc.nvidia.com. It's a catalog list of applications available there. Try it out. Okay, next, it's very important for you to understand the whole NVIDIA ecosystem that we have for your developers' benefit. If you go to the website developer.nvidia.com, under the developer programs, there is many resources. It can go by industry, whether it's a finance industry, gaming, healthcare, public sector, media, entertainment. There's many more. So all the SDKs, libraries, platform are grouped by industry. Next, you can even look at resources, right? How do you join the developer program? There's a lot of benefits activities over there. If you want to do webinar-based type of training, go and take a look at a training. If you are a professor or a lecturer who's lecturing in the university or college, or even a school, you want to go and take a look at the materials available under training and educators, right? NGC I've shared already. And the other one is NVIDIA GDC. So GDC is NVIDIA's world's largest conference for developers. So I would recommend highly for you to come and join the NVIDIA, I would call the, we call GDC on demand session. Right? So you just join in as a developer. It's free. It just takes a couple of minutes to fill up the form. You fill up the form, you will be able to get the access to this GDC. We have over 20 years of GDC contents. I mean, many may not be available over many years, but for the past several years, all these contents are being maintained relevant to your technology and work. So I highly encourage you to go and watch GTC on demand. Right? And then there's many open resource, open source code that you can get it from NVIDIA GitHub for startups and playground. So please be an NVIDIA developer, sign up and benefit from the programs that we have. Okay, for those who are building solutions, if you look at it here, we have based on area, data science, right? There is many type of framework, either conversational AI, deep learning, inference, machine learning, federated learning, right? AI-enabled video analytics, all those available. If you're working on a video broadcast and display related, look at all these libraries fresh and also compact and various areas being supported by the SDKs will help you, right? Whether it's a display related or HMD, head mount device related, video encoding, decoding, upscaling, downscaling, all this is available under the video. HPC, those who are working on HPC, scientific computing, many work has been done. A lot of libraries platform for you to look at it. Similarly, for intelligent machines in the robotic space, working on a hardware related area. Then if you look at the rendering, image processing, ray tracing is over here, simulation, game engine, networking, in autonomous vehicle space, if you're doing some kind of a tools management, telecommunication, all these are being supported by many of our SDKs library platform. The next view, you can actually take a look at it by the platforms, right? Area. So go through, I will share the slides after this. You can take a look at it, or you can even go direct to the website, developer.nvidia.com, and take a look at it, right? Okay, finally, for startups, we have a program called NVIDIA Inception Program. So I highly encourage all the startups to join the program and benefit from the program. So a colleague of us, which is Vanessa, drives the program for the region, including there's many Thai startups joined, but we welcome many of you to join in. And it has many benefits. One example of a benefit is you get access to NVIDIA experts to talk to get advice. Right? Second is you have the benefits of getting discounted hardware if you want to buy the hardware. Next, you have access to get some kind of compute credits from NVIDIA, right? It's a free for compute that if you want to get started with your application development. Next, you have a marketing benefits which comes together with startup as you achieve a certain stage of implementation. You want to get help from NVIDIA, marketing help is available. Right? And NVIDIA also runs a program called GPU Ventures Program. If you're looking at connecting to a VCs, then GPU Ventures Program will help you to connect to VCs. But NVIDIA facilitates the discussion between you and the VCs to continue the discussion for growth of the startup. So it's a whole new program and a lot of benefits you can get it from NVIDIA Inception program. Join and today, right? So next is for those who are working on higher education. There's a lot of resources available for you as well. So go to the website. As you can see down there, there is a website there. If you're a researcher, there is a different set of benefits are there. If you're an educator, there is a different type of benefits that you get. Teaching Kit, for example, for the lecturers and teachers to download the whole content so that you can use it to deliver your classes with the industry professors, develop the content for one semester, right? The next is for students, for those students who wants to learn a lot of programs that we have, right? Whether it's Jetson skill-based, whether it's a student workshop, webinars, self-paced certification, all that is available at no cost to you, right? All that for researchers, educators, and students, all these are actually at no cost for you to benefit from NVIDIA HER program. And there is a DLI. I would suggest go to the DLI website, and there is a lot of online DLIs free. You can take it. And also, of course, you can sign up for some of the DLI program. Just pay some small amount of money. You can take the online courses, and you will get NVIDIA certificate, right, as you complete the courses. Okay. This is just in a nutshell, as I shared with you, Teaching Kit, and also DLI Ambassador program that you can benefit. So example of Teaching Kit that we have is in the space of deep learning, right? So this deep learning actually comes with rich content. There's many other programs, but deep learning is something which is famous, available. So we have parallel compute Teaching Kit, we have a deep learning Teaching Kit, we have robotics Teaching Kit, we have a data science Teaching Kit, we have a metaverse Teaching Kit, right? So it has content of lecture slides, lecture videos, hands-on lab, solution, quiz, exam, and so forth, which will help you as an educator and a student. This is an example of deep learning content. It's available. So this was developed together, partnership together with Professor Lee Ya-kun. He's one of the modern father of AI. Okay, so I would come and stop here and ask for questions from the audience so that it becomes an interactive session between us. Do you have any questions for me?
โอเคถ้ามีคำถามสามารถพิมพ์ในคอมเมนต์ได้เลยนะคะโอเคระหว่างนี้ตอนที่ยังไม่มีคำถามนะคะก็อยากสรุปสั้นๆนิดนึงที่ Ethical Share วันนี้ก็NVIDIA เราก็จะมี SDK framework ต่างๆสำหรับ develop ทั้งจริงๆแล้วมันจะ cover 3 เรื่องนะคะก็คือ AI HPC แล้วก็สิ่งที่เราเรียกว่า Omniverse ที่จะไปช่วยเรื่อง Metaverse เนาะอาจจะทำอวตารทำ Virtual World Digital Twin Robot Gym Human Gym อะไรก็ว่าไปนะคะซึ่ง Ethical ก็จะมีโชว์ตัวอย่างให้ดูบางส่วนเนาะเช่นในมุม AI ที่เป็นแพ็คที่มีริว่าใช่ไหมคะมีถูกคิดอะไรเงี้ยก็คือมันจะมีเป็น end to end solution เลยนะคะแล้วก็HPC SDK เนาะก็คือเราไป leverage อันต่างๆที่มีอยู่แล้วอะค่ะ move มันมาใช้บน GPU แล้วก็มี approach ใหม่ๆให้ด้วยนะคะแล้วก็ Omniverse เนาะอันนี้ก็ช่วยในการทำอวตารใช่ไหมคะแล้วก็เช่น โชว์ตัว audio to face ด้วยก็คือเทรน muscle มาให้แล้วค่ะนี่เราก็ใส่เสียงเข้าไปแล้วก็แล้วก็เทรนแบบให้หน้าขยับแล้วก็มาจูนให้สวยงามเหมาะสมอีกทีนึงอะไรประมาณนี้นะคะแล้วก็นอกนั้นน่ะมันก็จะมี tool มาช่วยในการคือมันก็จะต้องบอกว่าเวลาเราทำเราไม่ได้ใช้แค่ตัวเดียวก็คือมันเป็นเราใช้หลายอย่างประกอบกันเนาะเราสามารถหยิบบางส่วนเช่นสมมติเราเทรนหุ่นยนต์เราก็แบบเอาตัวที่ช่วยทำ data อะไรเงี้ยมาช่วยคือมี approach ต่างๆที่ช่วยให้เราแบบร่นระยะเวลาในการทำให้มากที่สุดแล้วก็จริงๆแล้วเรามี SDK cover ทุก industry เลยซึ่ง Ethical แค่โชว์บางส่วนแต่ว่าอย่างในแฮกเกอร์ตอนครั้งนี้ค่ะมันก็จะมี healthcare ด้วยเนาะแล้วก็อะไรนะ insurance ซึ่งแบบเราก็สามารถแอปพลายหยิบบางตัวไปใช้ได้เช่นตัวแบบ recommender ที่ชื่อว่า Merlin ที่ Ethical พูดถึงอะค่ะอันนี้น่าจะใช้ได้กับแทบทุกอันเนาะแล้วก็แพ็กที่ไป accelerate data science ใช่ไหมคะยกตัวอย่างตัว Rapid อะไรอย่างเงี้ยนะคะแล้วก็อื่นๆก็มีoverview เนาะในมุมสิ่งที่ NVIDIA provide ในมุมมาช่วยในการ accelerate คือ NVIDIA ไม่ได้มีแค่ GPU อันนี้มันก็จะเหมาะกับหลายๆ use case แต่ว่าถ้าสมมติแบบว่าไปทาง HPC อะไรเงี้ยก็อาจจะลองก็รู้ไว้อาจจะแบบเป็นการ overview ไว้นิดนึงว่าเรามีCPU ด้วยอะไรเงี้ยนะคะที่เราเอามา accelerate HPC ซะเยอะต้องบอกว่าทั้ง CPU GPU DPU ทุกอย่างของ NVIDIA ไม่ได้ออกแบบมาสำหรับ general purpose ก็คือเราโฟกัสมุม AI มุม HPC หรือเอามา accelerate แทบไม่ใช่ทั้งหมดก็คือทั้งหมดเลยนะคะค่ะโอเคแล้วก็มีนิดนึงก็คือ NVIDIA มี Inception โปรแกรมเนาะอันนี้ก็คืออยาก encourage ให้ทุกคนมาสมัครอันนี้ก็คือเป็นโปรแกรมสำหรับสตาร์ทอัพก็มี benefit ต่างๆมากมายแล้วก็ที่สำคัญก็คือจะได้แบบว่าเข้าไปมีแหล่งที่เป็นรีซอสให้เราเข้าไปหาข้อมูลนะคะไป connect กับ developer อื่นๆทั่วโลกแล้วก็มีโอกาสที่NVIDIA จะช่วย dive ในมุมคือมันก็จะมีพรีเมียร์โปรแกรมด้วยอะไรประมาณนี้นะคะเพื่อที่จะไปลิงก์กับแบบทั่วโลกได้อะไรประมาณนี้เนาะค่ะแล้วก็อื่นๆในมุมสำหรับ education เราก็มีหลายอย่างซึ่ง Ethical Show ก็มีตัวteaching kit ใช่ไหมคะแล้วก็มี ambassador โปรแกรมมีทั้ง student ambassador แล้วก็ทั้งแบบว่าที่professor นะคะก็อันนี้ก็คือถ้าสมมติ certify แล้วอะค่ะก็จะมีสถานะอยู่ได้ประมาณถ้าจำไม่ผิดประมาณ2 ปีนะคะแล้วก็มาต่อได้แล้วก็สามารถหยิบคลาส NVIDIA ไปสอนได้ซึ่งEthicalมีโชว์ตัวอย่างเมื่อกี้ไปประมาณ5คลาสเนาะแล้วก็ให้ดูว่ามีอะไรบ้างนะคะก็จะมีแบบว่าเป็นเราสามารถเรียนเองได้เลยนะคะมี lab มี quiz มีอะไรอย่างเงี้ยให้เราสามารถfollow ตามสเต็ปได้เลยค่ะโอเค so Ethical I just do some lab but actually I think because it's like still in working time not many people joining and they can watch it later so they can leave question and comments and let's see maybe we can answer them after that yeah
so I also shared a link for those who are new this is like to understand how the simple deep learning actually works. So try this offline for those who are new. For those who are already working in industry, please go through let me share the link, which is the DLI Institute of NVIDIA. It has many courses that you can actually take at your own pace. You can learn on your own. I'm sharing the link to you based on the area that you are interested. Explore these sessions, which will help you. The first one is, very simple introduction for those who are new to deep learning and understand that. The second one is collection of all the SDKs and libraries so that you can work on this and benefit from the session. Yeah, so we have small team. So I just wanted to make sure that they have all the links after this so that they can actually watch and learn offline. Right? So for some of other sessions, so how are we going to make the slides available to them, Pankyo?
Let me share to BOTNOI team, and I think they have a group of people who join the hackathon that they can share via that channel. Yeah, you can send to me.
Sure. Okay, good. I'll share the slides and you can, put it through send. Yeah, sure. So the next link I shared with this, which is the GDC. Please go here for GDC on demand sessions, right? There's many interesting sessions that I would suggest for you to go and learn, especially latest topics in Gen AI related area. Many interesting publications, research work is being presented. Okay. Okay. I think that's all I have for today. For those who tune in and join, thank you very much. And also thanks to Pankyo for getting this organized and also brought.
Okay, thank you so much. Etiquette, I will also share them our NGC, but actually you mentioned that they can search the. I'll share them the link to that also. Thank you so much.
No problem.
Okay. Have a good day, everyone. Okay. Bye-bye.